Okay, good morning class. So at this point we are busy with equations. You had homework, it was exercise 4.9. I selected a few sums for you to do there. Is there any issues with the homework? With 4.9. Which sum is the problem in 4.9? Any problems with number 1? Huh? No. Number 2? A? A is a problem. Okay, so let's look at A. So firstly I need to get it in. Okay, so let's do this equation 1 and equation 2. Which method did you apply? Who's asking this question? Who said I must do this one? You. Right. Which method did you apply? The elimination or the substitution method? Right. Okay, no problem. So what was the first step you did? So you say negative x?
Minus plus 3y minus 5.
So you wrote it as 3x plus 2y minus 29 equals 0. And then you said negative x plus 3y minus 5 is equal to 0. Is that what you did? Okay, which is correct. And now what did you do? That's right. But now we want to must eliminate one of the values, one of the variables, sorry. So let's go and eliminate the x. If you're going to eliminate the x, then this line here must be multiplied by what? By 3. So 3x plus 2y minus 29 equals 0. But multiply this line by 3. Why by 3? So that the coefficients here can be the same. Okay? So that's now going to give you negative 3x plus 9y minus 15 is equal to 0. So what do I do now? Just add them. Do I add or subtract? Add. Why? Because that is already plus and a minus. If it was both plus, then I would have subtracted the 2. So that would have given us 0. That's going to give you 11y minus 1344 equals 0. So 11y is equal to 44. Divided by 11, y is in. So what do I do with that? I substitute that into any one of the previous equations. Yes, Michael? Then I would have subtracted the 2. So then by subtracting it, one would have become plus and one would have been minus. Okay. So it's going to be 3x plus 2 times 4 minus 29 is equal to 0. So it's 3x is equal to 29 minus 8, which is 21. 3 divided by 21 is 7. Okay. Who else had a problem with A but did the substitution method? You did the substitution method. Okay, so let's see. So this is the elimination method. That's why I only wanted to show you one method. But anyway. So the substitution method which would be the easiest to make the subject of the formula here? The second one. And what we're going to make the subject of the formula here? X. So I take x over the equal sign. It becomes x equals 3y minus 5. And this equation, 3. Okay? Did you do that, Michael? Huh? Yes. So now we will substitute equation 3 into equation 1. So that's going to simply be 3 into 3y minus 5 plus 2y minus 29 is equal to 0. So get rid of the bracket, so it's going to be 9y minus 15 plus 2y minus 29 is equal to 0. That's going to give you 11y, and this is going to give you negative 44. You take it over, it becomes 44. Divided by 11, so y is 11. Okay, so what do we do with that? We substitute it back into equation 3. So x is equal to 3 times 4 minus 5. 3 times 4 is 12 minus 5 is 7. Is that what I got earlier on? Okay. Where do you make a mistake?
So, after we the equation 3 equals equation 1. That will put my alpha equation 3.
So you got them, made a mistake in deriving equation 3. Okay. Anybody else?
Sir,
Yes?
I also used the substitution method, but then I said x equals negative 3y plus 5. Then I divided them both by negative 1.
So you see your mistake you made? Huh? No, you don't see your mistake. Okay. So let me just follow your logic. So you did this method. Yes, okay. So you got equation 3 out, like this. What do you have?
I said x equals negative 3y plus 5.
That is correct. But then you had to divide by negative 1. Did you? Which gave you what?
X equals negative 3y plus 5.
Which is what? So you left it like it. Like it. But this must be simplified. Each one of its own, negative divided by negative is positive, so it's 3y. Positive divided by negative is negative 5. So x is negative. X is equal to 3y minus 5, or minus 5 plus 3y. Okay. Anybody else? Any problems with C? Anybody had a problem with C? Yes? This was on what page was this on? Okay, exercise 4.9. Anybody have a problem with C? No. E? G? Anybody with G? I? Okay? You all say no, put it in an exam and everybody gets wrong. Not a joke. Alright, for homework I would like you guys to do the remaining sums of exercise 4.9. The remaining sums of exercise 4.9, number 2. Then we went into problems leading to quadratic equations. Correct? Okay. So I'm going to do that example there. I know I gave you 5 sums for homework, no? We're going to do all 5 now. But importantly, I just want to have a look at these examples first, okay? These examples are on page. Somebody give me the reference?
91.
Page 91. Oh yeah, here's the first one. Example. Okay, example 1 on page 91. So here we are told that a cool drink you usually buy is on special offer today. Okay, the price has been reduced by 2 rand a can. Okay, so what we do is we let the normal cost be X. So if the normal cost is X, then the new price, so the reduced price, is equal to X minus 2. Okay. This means you can get 14 cans for the same price. Now the same price is, we all set it equal to each other. Okay. This means you can get 14 cans for the same price that you usually pay 10 rand. So the usual price or the normal price is X. 10 cans, so it's 10 times X equals 14 cans is 14 into X minus 2. You guys understand the operation? Here it says, this means you can get 14 cans for the same price. Well, how do you calculate the price in total if you're going to buy 14 cans? 14 times the cost per can. Or, in the second part, they usually pay for 10. So how do you get the total cost for 10 cans? 10 multiplied by the cost itself. The price, the usual price. Does it make sense? So from here, it's just a matter of solving for x. So it's going to be 10x equals 14x minus 28. They get over the equal sign, so it's negative 4x is equal to negative 28. So x is equal to 7 rand per can. The question was, what is the usual price of the can? The usual price is 7 rand. You guys understand? Okay, let's do another one. And we have example 2 on page 91. So in example 2 we are told that the 10 digit of a 2-digit number is 2 more than the units digit. So yesterday we spoke about a 10-digit a number where the numerical value of a 2-digit number will be the tens digit is x and the units digit being y. Okay, so we're going to use that same idea that we spoke about yesterday in this sum here. Okay, so again, the 10-digit number, the tens digit of a 2-digit number is 2 more than. So that means to say, if we let the tens be x and the units be y, okay, the 10 digit of a 2-digit number is 2 more than. So in other words, if I say whatever x is and I subtract it by the units digit, I'm going to get an answer of 2. You all agree with that? Here again, the 10 digit of a 2-digit number is 2 more than the units digit. So if I subtract the tens and the units, I must get 2. You guys understand? Then, if so this is equation 1. If the digits are reversed, the sum of the 2 digits is 176. So if you're looking at the original number, So we'll let the original number be x 10x plus y. If the numbers are reversed, we swap it around. If I swap this around, what do I get? That's the first number. If I swap it around, what do I get? 10y plus x. You see, if the numbers are reversed, okay, it gives you the sum. That's why I put the plus here. The sum of the two numbers is 176. What are the two numbers? So let's check. Here we're going to add like terms here. So 10x plus x is 11x. Y plus 10y is 11y equals 176. I divide by 11. So x plus y is equal to. What is 176 divided by 11? By 11. Sorry? 68? Check. 16. She says 16. She might be right. You're looking in the book? No. Nice. So this is the equation. So at this point, I either can do substitution method or elimination. Okay? The elimination method is going to be the easier method. Okay? So now we're going to do add equation 1 and equation 2. Do we need to change the signs on the line here? No? Why? Because the y minus y cancels. So I got 2x equals 16 plus 2, 80. Divided by 2, 9. Not so. If I substitute that back into one of the previous equations, so it's going to give you 9 minus y is equal to 2. So y is equal to 9 minus 2, which is 7. So the two-digit number is 97. Why? Because the x was 10 and the y's were the units. Okay. So that's it. Then you had exercise 4 to do. Okay, any problems with number 1? Anybody have a problem with number 1? Number 2? Number 3? Huh? Somebody said number 2. What did you get for number 2? 36. What did you get for number 2? You didn't do number 2. My word. Okay, anybody else number 2? You hearing things? Oh my word. Number 3? No. Number 4? Number 5? Right, number 4. Ndiwe is twice as old as Priya. So we have Ndiwe, we have Priya, and we have Sue. Ndiwe is twice as old as Priya. Between the two, who's younger? Priya. So Ndiwe is twice as old as Priya and 6 years older than Sue. So between Ndiwe and Sue, who's older? Ndiwe. So at this point, we can say let Priya be X. Normally we just let the smaller one be x. Okay, so between the two, pre is x. Then how old is the dy in comparison to pre? 2x. Not so? Now, remember the dy is 2x. Then dy is 6 years older than Sue. Then dy is 6 years older than Sue. So Sue will be 2x minus 6. You guys understand? Their combined ages total 39 years. Which means to say 2x plus x plus 2x minus 6 is equal to 39 years old. So that's 5x is equal to 39 plus 6 is 45. Divided by 5 is going to give you 9. So then dy 2 times 9, which is 18. The question is, how old is dy? Dy is 18. Priya is 9 and Sue would be 12. Okay. You guys got it? Don't lose it, okay. Number 5. A plumber charges 240 Rand per hour for labor. So we say let the number of hours equal X. So if he charges 240 Rand per hour, whatever amount of hours you work, you must multiply that by X. By however number of hours you work, you multiply that by 240. What's wrong, Michael? You look like you went to a scale or something. Oh, okay. Not today. Say what you want to say. Why is she look so scared? Huh? You're scaring her? Not today. A plumber charges 240 Rand per hour for labor plus a call out fee of 60 Rand. Okay. When he repaired Mrs. Mofo King's, nah? Is that right? Yeah. Mofo King. Mofo King's leaking pipe, he charged her 540 Rand. I'd rather become a plumber, nah? And listen, this was more than 10 years ago. So this book is fairly old. No? I think they charge now, call out fee of 350. 350. That's why I say rather become a plumber. No? Okay, the question is, how long did the plumber take to make the repair? So in other words, if you charge 540 Rand. Okay. Sorry, how? You see what I'm talking about? No. They probably do now. 500 Rand now. Listen, the guys make money. Your leak, you can't get your leak sorted out. And they it's like, I don't know. But anyway, so we take solve for x here, we take that over, so it's 240x equals 540 minus 60 is what? 480 divided by 240, both sides. So x equal to 2. So you're telling me it take 2 hours to fix a pipe? A leak? I think he was doing something else there. No? Maybe Miss King gave him tea or something. Why you know? No? He is maybe having lunch or tea or something with his auntie. Okay. The leaking pipe goes quick. No? So you say he wants more money, so he's taking his own time.
Yes, I would do that.
You do that. You didn't even start working and you're thinking of ways of conning people. Right? How do we build a nation with people thinking like this? Ow. Sorry? Some of us need money. But you can't just con somebody else. Isn't that fair? You think it's fair? Yes, no. How can you say it's free? It's Ramadan. You mustn't. Right. People, for homework. I gave you numbers 1 to 5. You do number 6. To 11. 6 to 11 for homework. So today we're going to look at linear inequalities. Linear inequalities. Okay. Little note I want you guys to make on the side of your page. Put it in not a coffin, a box. Yeah. The coffin's a box, isn't it? Yeah. Yes. Right, here we go. Yes? Quick. Today? Thanks for the reminder. Now we must first do geometry. Right, note. A linear inequality is an expression with the highest power of 1 to the variable and with the signs great more than, less than, or more than and equal to or less than and equal. Okay, so linear, it basically means just that the highest exponent exists, 1, or on the variable. Okay, the question says solve the inequality 3x plus 3x is less than 9x plus 4. So before we go into solving this linear inequality, who can read this inequality here? X is? Who says less than? Somebody shouted out less than. Who says more than? Taba, what do you say? Huh? You say that is x72. No, Taba, man. Okay. That is x is more than. What does that mean to say? X is greater. It means to say that x can be any value that is greater than 2. For example, 3, 4, 5, 12, and so on. So since you like me to send you back? Huh? So you're coming from one class to the other to make jokes here? Okay. So you can go all the way to infinity. Not so. Remember, one of you guys can go in her place to that class. Huh? You went already?
No,
Someone went. Okay, no problem. Don't say which one. Don't know which is anyway. So, if x is greater than 2, it can be any value from 2 2 onwards all the way to infinity. Not so? So who can read this inequality for me? X is greater than 2. It's the same. As long as the inequality is open to the x. As long as the inequality is open to the x, is considered to be greater. What is this here? X is more than or equal to 2. What does that mean? It can be. So which numbers can this inequality be? 2, 3, 4, all the way to infinity. Not so. Or any value. It could have been 2.5 as well. This here could have also been 2.5. Unless they told you that x is an element of natural numbers. Then it can only be 3, 4, 5, 6, 7 and so on. Since that was not specified, this can be any value greater than and equal to 2. Do you guys understand? So what would this be? X is greater than 0 and x is less than and equal to 2. You guys understand? So can x be 0 here? Can x be 2? Yes. Why? Because it's equal at the 2 and it's not equal at the 0. Therefore it's omitting the 0 and it's including the 2. Okay. Now coming back to the question that we have on the board, the sum we have on the board. It says solve the inequality for 3x is less than 9x plus 4. So what do we do here? As we do in an equation, we take this 9x over the equal sign. So what would that now become? 3x minus 9x is less than yes.
So I think that
The inequality. The inequality. Don't say thingy.
inequality
Yes.
is an equal sign.
We can treat it to an extent as an equal sign. Once we're solving this equation, it is as if it's an equal sign. But you'll see now there's different rules that apply. Okay, so we took that 9x over. So what is that now giving us? Negative 6x must be less than. Not so. So what do we do now? Now before we go into that, no? Let's go again. We got 3x is less than 9x plus 4. Okay. So what I'm going to do is I'm going to take a 3x this side. Okay, and I'm going to take a 4 on the other side. Then what would it read now? 9x minus 3x equals negative 4 on that side. What is 9x minus 3x? 6x negative 4. So how do I get x on its own? Divide by 6 both sides, not so? So that cancels. So we have x is greater than negative 2 over 3. Not so? You all agree x is greater than negative 2 over 3. Let's go on this side. Divide by negative 6 both sides. That cancels. So x is less than. That goes twice and 3 times. Negative 2 over. Read the inequality. What does this say? X is less than negative 2 over 3. But what did this say? X is more than 2 over negative 2. Is the answer the same? So here is a rule I want you guys to write next to this. When you're dividing or multiplying by a negative, when you're dividing or multiplying by a negative, swap the inequality around. When multiplying or dividing by a negative, swap the inequality around. That's only when you're dividing or multiplying by a negative. Okay. This you. Then multiplying or dividing by a negative, swap the inequality around. Yes. So if you're going to divide by negative, you see I'm dividing by negative here. So what must happen to the inequality? Change. So read the inequality now. X is more than or greater than negative 2 over 3. Look at the side. X is more than negative 2 over 3. Can you see the side? So that is very important. When you're dividing or multiplying by negative, you will swap the inequality around. Okay, you guys got it? So, if the question says, illustrate this answer on a number line. Illustrate this answer on a number line. What we do is we draw a number line. The important or the critical value here is going to be negative 2 over. Okay. So, on the number line, if something is more than or less than and more than, whatever. On the number line, it will have an open circle. Which means to say, it's excluding. Okay? And if you have more than and equal to or less than and equal to, it will then have a closed circle on the number line. Why? Because it's including. Right? So make that note there. Another table. This is excluding. And this is including. Excluding and including. Excluding will have an open circle on the number line, and including will have a closed circle. Did I mix it up now? Excluding will have a open circle on the number line, whilst including will have a closed circle on the number line. In your inequalities, if it's more than or less than, it's excluding the number they are referring to. Whilst more than and equal to or less than and equal to, it's including the number they're speaking. Okay. So, would this inequality have an open circle or closed circle at negative 2 over 3? Open circle. Why? It's excluding. So read the inequality. X is greater than negative 2 over 3. So do I go to the right hand side of the point or to the left hand side? The right hand side. Why? Because that is in the more than direction. Not an O, it's an open circle. It looks like an O, no? Not an O. It's an open circle. Verstaan julle? Right, laat ons dit nog 'n enetjie doen. Let's try another one. The rules of inequalities, very important here. We're going to go through them now quickly. You can rewrite this in your books as part of your homework. It's very important, okay? Learners always get confused with this work, okay, with this rules, with these rules. And this is on page 97. So rules for inequalities. Adding or subtracting any number on both sides of an inequality has no effect on the sign of the inequality. For example, if you all agree that 3 is greater than 2. If you add 5 on this side and you add 5 on that side, it's going to become 8 is greater than 7. Subtract the same number on either side. There's negative 1 and you got 0. 0 is greater than negative 1. Can you see that, people? Same like an equation. If you add the number on either side, the equal sign, the equation is still balanced. Okay. Then the next one in rule 2 says multiplying or dividing both sides of an inequality by the positive number has no effect. So if 3 is greater than 2, if you multiply this here, it will be 6 and 9. 9 is still greater than 6. You divide both sides, it's 2.5, so 0.2, and this is 0.6. 0.6 is still greater than 0.2. Okay? That's basically what we're saying there. Multiplying or dividing both sides of the inequality by a negative number reverses the inequality. We just spoke about this now. Not so? So for example, you got 6 and 9, you multiply this by 2, you get negative 18. You get then negative 27. Is negative 18 greater than negative 7? Yes. Can you see that, people? This one is a bigger negative number is much smaller. Likewise here, the same story here. Divide both sides by negative 3. This is going to be negative 2 is greater than negative 3. So again, this is the rule that we made a note of earlier on. When we're dividing or multiplying by a negative, the inequality swaps around. Okay. The next question, the next rule says, taking the reciprocal of inequality reverses the inequality sign. For example, so if you got 2 is less than 3, if we take it reciprocal, that's most flipping the fraction around. There's 1 over 2. A half is greater than a third. Not so? So by taking the reciprocal on either side, also swaps the inequality around. So that's a note you need to make there. And then number 5, rule 5 says, never multiply or divide an inequality. Never multiply or divide an inequality by a variable unless you know whether the variable is positive or negative. Okay. Why? Because why? If you don't know if the variable is positive or negative, if it's negative, the inequality must swap around. If it's positive, the inequality must stay the same. You understand why they are saying that? Okay? Unless you know it's positive, then you can multiply across the inequality. Okay, so that is important to note at this point. Okay, we'll do another example. No? Yes, okay. Right. This is on page 97, example 1 on page 97. The question says solve for x. Solve for x. Right, write this down. And the answer we're also going to illustrate on the number line. Okay. Okay, this is a 2 here, no? Yes. Right, so what do we do first? Times round by 2. The LCM is 2. So you multiply this by 1. Must be more than or equal to. This must be multiplied by 2, which gives me now 6 into x plus 1. Not so? Right, solve for x. So what do we get? 2x minus 3 is more than or equal to 6x plus 6. You all got that? Right? So x is one side, now this other side. What's long here, Jan? Just putting your face like that. Why are you laughing? You are laughing today. Huh? Yes. Huh? Huh? Yes. Nice. Glad you love. Alright, what do we do now? X is one side, number is one side. So I'm going to take the 6x over and that negative 3 on the right hand side. So I got 2x minus 6x is more than or equal to 6 plus 3. What is 2x minus 6x? Negative 4x is greater or equal to 9. Divide by negative 4 both sides. So x equal to, x is greater than or equal to negative 9 over 4. You all agree with that? No.
Oh, yes.
Yes. Don't just say yes for everything. So x is less than or equal to negative 9. Who got that right? You didn't swap the inequality. How can you get it right? You swapped it. Yes. Okay, nice, nice. Now why you say yes for me? You weren't looking. Right. Now illustrate this answer on a number line. Let's see. If you know what to do there. Sorry? Sorry? Black circle. Close. Closer. Closer. So we'll have a closed circle, she says, at negative 9 over 4. So read the inequality. X is less than or equal to negative 9/4. Which direction? Left. It was less than, it's smaller. This was going in the smaller direction. So if you got 3 and 2 and 4, if you say less than 3, that direction. These numbers are smaller than 3 or they're less than 3. Not so? If it says more than 3, it's in that direction. Why? So these numbers are greater than 3. Can you see? Is 4 not greater than 3? Why are you guys laughing? Right, there's a 2 in 1 here. Nice. I like this one. 97, page 97. Two in 1 year. Just write it down. Just write it down. I'll explain it. You don't have to make everybody scared. Yeah? Yes. Why? You like me to see the papers? Yes. But the marks doesn't say you like it. Okay. People, this question says solve for x. If x 1 minus 3x is greater than or equal to negative 5, but less than or equal to 10. Write the answer in interval notation and illustrate the number. For now, we're not going to write in interval notation. Okay, we're going to master this first. So, if you got negative 5 is less than or equal to 1 minus 3x is less than or equal to 10, the idea is to isolate the x, to get x on its own first. So that 1 goes that side and it goes this side. It's like a 2 in 1, the man with 2 wives. You know? So you give the one, you give the other. You know that, no? Yes, sir. Right. So it's negative 5, you take 1 over becomes minus 1. A chief, you guys got chiefs, no? 10 minus 1. No? You guys have chiefs. No? Huh? Don't you guys have chiefs? Don't you guys have chiefs? Eastern Cape. Okay. We in Western Cape, no chiefs. Okay. So minus, okay, so relax. Minus 5 minus 1. Negative 6. Negative 3x. 9. What do we do now? Divide by negative 3. What's going to happen to the inequality? Swap around. So let's read the inequality. X is greater than or equal to minus 3. But x is also less than or equal to 2. So if you have to draw this on a number line, minus 3 and 2. Would negative 3 have an open or closed circle? Closed. 2. Read the inequality again. X is greater than or equal to negative 3. So which way? Left or right? Right. But x is less than 2. That is going? There we go. Okay. For homework, you do for me exercise 4.12. You do for me You do for me the odd numbers. Exercise 1.12 on page 98. You do for me the odd numbers. People enjoy the rest of your day. Good morning, class.